Many of us are probably pretty familiar with the bright shiny object syndrome in the security space. There's some new initiative, some new buzzword, some new framework that people come up with that becomes all the rage, and then they have conferences about it. And it's in that spirit that I'm looking forward to our next presentation. It's by David Middlehurst, who's a principal security consultant at TrustWave Spider Labs. He has worked with many high-profile clients conducting penetration tests and red team exercises, and for the past 4 years, he's gained extensive experience carrying out adversary simulations for clients. He's presented his research at several security conferences, including B-Sides London and the NCSC's Cyber UK. Please welcome David Middlehurst.
Hello, everyone. So it's a great privilege to be here, and I want to first of all thank all the organizers and how professional and supportive they were, particularly Adam, who I had some interactions with prior to my presentation. I want to start off with, I noticed pass the hash here. So does anyone know how old pass the hash is as a technique? Go on.
1997.
Yeah, and it was so pass the hash was coined in 1997, which is 21 years ago. And I know this mainly because I did some long-term consulting gigs with a guy called Paul Ashton, and he works at a previous consultancy which I worked for, and I managed to work alongside him. He's an amazing guy, and interesting thing about him is he's probably never had Windows as a base operating system in his life, which is quite interesting given that his technique. So this is my presentation, playing devil's advocate with security initiatives with ATT&CK. I'll explain what that means a little bit later. But first of all, I wanted to just go through a rough agenda of what I'm going to talk about today. So I'm going to start off with a bit of introduction about what I mean by this. We're then going to play devil's advocate with a few security initiatives. So I reached out to some colleagues, and we want to just play second guess them a little bit. And then I want to kind of come on to the bread and butter of my presentation, which is a command and control technique. And this is kind of a large-scale security initiative, which I kind of want to try and apply some of the wisdom of ATT&CK to. There's going to be a demo, and there's also, I'm going to drop some code today as well. It's kind of like a red team, well, it's going to be for a red team tool set, so you can take this away and start using it straight away, hopefully. And then we'll discuss some mitigations. So a bit of background about me. So I'm newer to the industry than pass the hash. So I started my career in 2009. I've worked only in computer security throughout my career, so I've not been a sysadmin and all that kind of thing. I've worked as a pen tester. I've worked a little bit into research, but kind of it's been in the sidelines up until recently. I've been doing more at Spider Labs, I guess. But probably more the reason why I'm here at ATT&CK and why I really like ATT&CK is that for the past 4 to 5 years, my specialism has been red teaming. This largely started out because of the rise of regulator-driven pen testing, regulator-driven red teaming in the UK. So this was probably one of the first frameworks for this was the Bank of England CBEST scheme, which I was heavily involved with. So this meant that I worked with some of the top-tier financial institutions. I saw how they've evolved over the years. How we've managed to beat them down and then go back in again, and they've improved and stuff. So I want to share some of that. But the overall presentation, like what am I getting at here with playing devil's advocate to the security initiatives? Well, I'm thinking maybe we can apply ATT&CK beyond offensive and defensive realms. So I use ATT&CK in making sense of my red team exercises and better communicating them with clients, for example, or when we're doing purple team exercises, sitting down with defensive teams to help them improve. But I think what ATT&CK does well is it, for the first time in any kind of logical manner, gets down some of the stuff which is in hackers' minds, and it's organized, those techniques, in a logical way. And I think we can leverage in that in a lot more than just offensive or defense, just any security initiative. This is, I think, important. So I've got a couple of examples. As I say, I've got one main example I want to get to, but I was just floating around the team and speaking to them and seeing, what examples. So this is an article from InfoSec Ireland. I'm going to zoom into some the main points in this article, but essentially this article, I don't know who wrote it, but it was a consultant who went into a client and they'd adopted smart card authentication. This was back in 2014, so perhaps things have moved on a little bit. But the important thing here is that the client had a bit of a chip on their shoulder. That it seemed like in the article that they thought they were immune to some of these lateral movement techniques. But in fact, their implementation, when the consultants went in, actually they'd made things worse. So now we're armed with ATT&CK. If we look at, when we're rolling out a security initiative such as let's adopt smart card authentication, which is obviously sounds like a good thing, and it obviously can be if you do it right. But maybe let's look at some of the techniques, in the matrix, and make sure we get this right and we validate that. Another one which I meet again and again on red team engagements, even more so recently, is multi-factor authentication. We've all been shouting for a very long time to get people to adopt multi-factor authentication, and I think it's obviously a fantastic thing and everyone should be doing this. However, I think there's a further distinction of how we kind of attackers are exploiting this. So for example, the spear phishing with a link. Say, let's zoom into, say, a credential harvesting campaign. There's two branches to that, the way I see it as an attacker. You can either host a page, you can collect the credentials, and then kind of reuse them later. But what's far less effort, and which is more effective in some respects, is if you reverse proxy in real time to a real piece of infrastructure, which is actually on the the target organization. So what you do in this sense is say they've got OWA, they've rolled out two-factor authentication, then what can you do there? Then, well, if you relay in real time, you can phish them with their own interface, but via you. So you get the the authentication cookie, you get the credentials, but the important thing is also you can patch out things like a logout function, so that you can gain access to the OWA, you can gain access to the Citrix environment. So what I'm trying to get at here is that obviously roll out 2FA, this is an important thing, but it's not necessarily a silver bullet, and we need to be careful about that and really delve into how attackers are evolving and how attackers are sidestepping this. The other two examples I've got there are if you've rolled out 2FA via an SMS approach, for example. This is quite hard to simulate in a white hat approach because it involves setting up a dummy carrier or something, but you're not necessarily immune. You're dependent on the adversary. You're not necessarily immune. If someone wants your 2FA token, it's via a text message. There are things which can be done, and there's some really like criminal activities with like the SIM swapping stuff. It's insane, like how they're compromising people who maybe work at carrier like retailers and stuff. The cases I've read about. So that's interesting too. This one's a more generic, high-level one, and it relates to something which was in the keynote actually. I think about I see red team and adversary simulation as a feedback loop, and this corresponds to where do you assign your effort. So you say you've got a limited security budget, where do you prioritize that spending of that budget? Well, I've done a whole spectrum of things from red teaming to configuration reviews, and I just think that maybe we should take a step back and we should look at the left-hand column of MITRE ATT&CK, so the initial access. We should look at things like MITRE pre-attack, look at how real attackers are getting in, and then prioritize those areas. One way of potentially doing this is performing in a red team exercise. And these sorts of things will drop out. Maybe it will help us prioritize this. I don't think, any good red team provider will give you a timeline of where the consultants have been, even the dead paths, so the paths which didn't lead them to the, the crown jewels, but, maybe they spotted something along the way which stood out to them as, something, legacy system, something which you maybe want to, investigate. So I don't think there's a single red team exercise that I've conducted where these sorts of things haven't dropped out. So maybe we should start with this and have it as a feedback loop. So John Lambert described using pen test report output or red team report output as an input to a security department. So I think that's something important we should think about. when it comes to prioritization. Securing the boundary, for example, is probably more important than configuration review of like a really nested system within your organization. Now, as I say, this is what I really want to talk about today. This is command and control has been a passion of mine a little bit doing the red team because I've learned the hard way. I've spent a long time composing really cool campaigns which have just not worked because the traffic's just not got out of some of the targets. So the way I see it is, and as you've probably been seeing, that I've tried to call out specific MITRE ATT&CK things for your bingo, obviously. Actually, this was before that. But this is the timeline of how I've seen what I've needed to do to get command and control to work in some mature targets. So initially, it was probably direct TCP. I probably didn't, I probably arrived after that. But so most mature targets don't allow direct connectivity to the internet from their networks, or they've got it really tight if they do. Then came HTTP based. So you only allow your proxy out. HTTP worked, so it went through the proxy, you get out. Then there was an evolution of let's look at HTTPS. So anything with a valid SSL certificate, that's secure, right? So let's just let it go. Then things got a bit harder. We went into things like categorized domains. So you needed to be in a finance category, a healthcare category within some of the proxy vendors. But then we found ways around that, maybe buying an expired domain, or maybe we forced a classification, a categorization of a domain. Then there was domain fronting, which is where you kind of exploit a CDN provider, or you become a customer of the CDN provider. You use an entry point, which is a trusted endpoint, and then kind of sidestep. Nowadays, this is kind of where we've got to, and I like the term C3, which I think MWR coined. Which is where you start using third-party services. Some of this is fairly interesting. I think there's been real-world attacks. If you go into MITRE ATT&CK and you look at some of the command and control techniques, there's people using GitHub, Twitter, that kind of thing for C2, because you're bouncing through a trusted server. Some are more useful than others. For potentially, most of the targets I work with, social media is probably blocked, but GitHub probably isn't if they're doing a development role. Something to think about. But this is what I really want to talk about, which is DNS over HTTPS. So DNS over HTTPS is a security initiative, which has some big buy-in, basically. So there's three big players in this game, as far as I can see it, which is Cloudflare, Google, and Mozilla. The aim of DNS over HTTPS is to increase user privacy, which is a good thing. Maybe not for enterprise, as we'll come on to, but also improve the security of DNS, which is inherently weak because of man-in-the-middle, people being able to snoop on it, as it goes along the data path. So these are some quotes from Cloudflare, and I think it's quite interesting. The second one where they say, if you're visiting cloudflare.com, anyone on the network knows you're visiting cloudflare.com, so we need to fix this. This is really interesting. This really when I first started seeing these services coming about, this really picked up my ears for a red teaming perspective, because I'm thinking, how do I do C2? This is really interesting. So again, Mozilla have started thinking about this, so that they're big people on board with this, and they've pushed out these cartoons and stuff to help the end users understand what they're trying to achieve. So as of Firefox 62, which came out, I think, in May this year, they enabled this feature. So it's not enabled by default, but it's there, it's present within the browser, where they wanted to trial using DNS over HTTPS as a resolver. So you can go in and enable this. If you want to do that, here's what they say to you do to configure it. Interestingly, here they've got their own Cloudflare endpoint to do the DNS resolution. I think that was so that they can kind of see the performance hit that the browser was taking. If you speak to anyone who works in the development of browsers, then performance is a really critical thing before they'll turn it on by default. But what it turns out is, and there was some media fairly recently, that it didn't take much of a performance hit, so that was a positive thing, and I think that they're going to continue with this security initiative. So moving forward, they said, well, we're going to continue to work with this, and we're hopefully going to enable it by default for all users, is kind of what I read into it. If you've read the news recently, in the InfoSec community, you'll notice that the RFC 8484 has just been published, I believe, which relates to this. I think that's only going to accelerate this traction. So coming back to me as a red teamer, what does this say to me? Well, I think that if we're enabling this by default in browsers, these browsers are going to be making these noises in the same way. Equally, all the infrastructure to be able to support this is going to have to be stood up. And probably one of the most important things about that is you've basically got an encrypted HTTPS endpoint which sits there and accepts connections, from an unauthenticated perspective by virtue of how DNS resolution works. So the best resource that I've found, which documents the public services that are out there at the moment, is probably this curl wiki here, which is linked. And they've got a collection of various ones. You can probably see, it's a bit small, but you can probably see Google at the top, Cloudflare. There's a few others there. So these services are out there. So, okay, we want to transmit data via these mechanisms. What we need to do is kind of understand how they work a little bit. So this is where I go a little bit more technical, so I'll kind of explain a little bit about how they work. So there's different ways in which you can call them, but the most popular one in the standard is the one at the top, which is basically you make a HTTPS GET request with a parameter of your lookup name, and then that will go and get the DNS record that you've asked for. You can also specify the type of record you want. As well, and also Cloudflare, but not Google for some reason, I believe, offers the DNS wireframe format. So that's where you can post a more familiar structure to your DNS request to their endpoint, and then it will resolve it and give you some binary data back. The other alternative in this field is DNS over TLS, which is, I guess, a more familiar protocol than DNS over HTTPS. I'm not going to touch on this too much, just wanted to communicate that that's there and that's an alternative. I noticed that I think that Android phones are going to potentially do that as by default. So that's another interesting track. It's an alternative here. But okay, to be able to actually use this to exfiltrate data, for example, we need to understand a little bit about how legacy DNS exfiltration works. So in this example, it's really simple. We want to send hello world. Basically, what we need to do is look at the DNS spec and look at how we can push it to its limits, essentially. So what we want to do is pick a sensible encoding which works for that protocol, and with the character sets and stuff. So in these examples, the bottom three, so the first one's just hex, but the second one's NetBIOS, the third one's base32. They're all valid, and there's probably a million other ways you could do this, but these are the common ones that I've seen in implementations. As I say, we've got to abide by the limits. So the way a DNS record split up, if you're doing a query, is that you have a series of labels up into a max length of 255, including the domain and the periods. So basically, this is an example of probably the longest query you can make. So this will be on the outward path from your victim out to the internet. Coming back the other way, you've got base 64 in a text record, can be up to 255 characters. You can also have multiple of these per response. So you've got a bit more data coming back that way. So that's from your attack server down to the victim. So this has already been done loads of times, and there's obviously MITRE ATT&CK, exfiltration alternate protocol. I think this fits into. If you're interested in DNS-based comms, then the first resource there, the Skull Security Wiki, is probably the best place to look, because they really go into the protocol and push it to its limits, and they make some design decisions and things about how they implemented DNS-CAT. So that's something to look at. But there's also these other things. But what I really wanted to do as a red teamer is I wanted to implement this for the common adversary simulation framework, Cobalt Strike. I wanted to I've been wanting to. This has been on my mind for a while, but I've wanted to actually go in and implement it because I think we kind of need to. From a defensive angle, I want to share this with the community, and I want people to kind of be conscious that this could happen. But equally, I want to implement it for a red team so I can demonstrate it to our clients that they need to kind of think about this. So. First of all, I had a pretty funny journey with this. So I started by thinking, the right way to go about doing this is probably external C2 spec, which is something which is new for Cobalt Strike, newish, where you can define your own command and control channel. But I'm thinking, this is just HTTPS under the hood. Beacon, which is Cobalt Strike's agent, already does this. We can maybe control it with malleable C2, and we get there. Well, that didn't turn out to be the right answer. Although you can do the right encoding, you've not quite got enough control over the underlying request to actually pull this off. So that was kind of a bit of a dead end, but I kind of got part of the way there, as you can see there. But then I had a brainwave. This is DNS. So Cobalt Strike does DNS, right? So can I use that? Well, okay, so let me have a look what's there and what's already in the public domain. I found a really interesting binary from Cloudflare actually called Cloudflare-D. They published this is a Go application, and I thought maybe I can package this into my payload and then set Cobalt Strike to kind of use that, which the Cloudflare-D binary proxies legacy DNS to DNS over HTTPS. So this is my try with this. It did turn out it wasn't the right way, mainly because the limitation of Cobalt Strike, it wasn't really, the DNS beacon in Cobalt Strike wasn't intended to work this way. It was intended as a covert channel when people had kind of forgotten to turn off external DNS resolution within a lockdown network. So you can kind of cascade the tree. You talk to your local resolver, say resolve-google.com. It then gets passed up the chain until it makes its way to Google, and then you get the response. So that's not really where it worked. You couldn't really hard code a local DNS server. So this is not the way I wanted to go. What I should have done straight off the bat, and I shouldn't be scared of the external to C2 spec, was use external C2 as within Cobalt Strike. So I eventually, managed to pull it off. But I think the biggest help that I got was, and we talk about community a lot, is that this guy, Ryan Hansen, hats off to him. He made a really awesome open source project called the External C2 Framework for Cobalt Strike. And this is his implementation in .NET of how you might implement some different channels. So I used that heavily. There was also some other projects as well, which I used. So like just a random DNS server in Python. Also, I mentioned that MWR had coined the term C3. So I know that MWR presented at Blue Hat earlier this year their presentation was called Overt C2, the art of blending in. I didn't see this. I wasn't at Blue Hat, but as far as I'm aware, they're going to release a framework which might make this easier for adversary simulation operators, that kind of thing. But I don't think they've released it quite yet. But for the time being, I kind of rolled my own, working with Ryan Hansen's code. So this is kind of what this will look like. So we deploy some code, some malicious code, I guess, to a victim. This will talk HTTPS to a DNS over HTTPS provider. That DNS over HTTPS provider will then talk legacy DNS to our DNS server, which will then talk to our team server and vice versa. So I actually got this working last week, fully, I guess, and I recorded a demo. What I've actually done since then is I've refined the code to get it to a standard where I can release it. So actually in the next break, I'm going to probably push it to GitHub if I can get some internet working. So this is the demo. So as you can see in the top right, there's a Python server, which is a DNS server. The left-hand side, you've got the agent running. In here, I've kind of simulated it in the sense that in the working code, it will stage itself over this protocol too. This is fully staged. As you can see, what's happened is it's sent the beacon metadata outbound. You can see in the bottom right that Cobalt Strike has picked up that. It's got the metadata. And what I'm going to do is I'm going to task it to run ipconfig. So as you can see on the left-hand side is what traffic you can. I've also echoed to the terminal what's happening and what resolution is actually taken. As you can see, the C2 from this perspective is going to https.dns.google.com, which is as a defender, that's what you're potentially going to see. It's HTTPS, so unless you're stripping, SSL in your organization, then, maybe you're going to see less than that. You won't see the underlying query, for example, the get parameter. As you can see here, what it's doing on the right, it takes a bit of time, and I've introduced an artificial delay here as well, that it's chunking the data. So as I say, it's pushing the limits of the DNS protocol. As you see at the bottom, the IP config's just appeared. So after 16 record lookups, it eventually got the whole of IP config. So it's relatively slow, but as I say, when I've streamlined the code, when I've streamlined the code, I've made this a bit more efficient. You could probably multi-thread it. And as far as I've seen, I've not seen any bottlenecks from the DOH providers, for example. So that's pretty interesting. So I'm going to have to speed up because I'm kind of running out of time. But this was a BERT capture of the results. All I wanted to show is if you actually do strip SSL, then there's maybe some IOCs here of this kind of technique, which you might want to look into. So I'm going to skip through this because I want to get through this. So that's not all, though. Can anyone tell me the significance of this slide? So this is some NS lookup output for 2 DNS records. Can you see what the significance of the IP address field is? So it's the same for both lookups. So for google.com, it's the same for dns.google.com. What that means, and I talk in Apache virtual host terms, this means that a virtual host exists on that IP address, which means that entry point, the IPv4 address, is at the same entry point for 2 underlying hosts. So what this means for me is that this is domain frontable. So we talked about domain fronting. This has been done before. So Google had App Engine, for example, where you could host code on Google, infrastructure, and they had the same entry point for that as, their search engine. But the interesting thing about this technique is that you don't need to run code on Google infrastructure. You're basically using one of their services as it's intended to be used. So you're saying, I want to resolve this domain. Can you go and do that for me? And they're like, yeah, cool. So this curl command shows me making an SSL connection to google.com. And then once that SSL tunnel is established, in the underlying HTTP packet, I'm setting the host header to dns.google.com, and then it's routing that onwards. So this technique, with a very trivial tweak to the code which I'll release, you can also use domain fronting and DOH, which is something I'm interested in. So finally, I'm coming to the end and running out of time, but I just wanted to discuss some mitigations. So this is a really hard problem to solve, in my opinion. The only real way you can get at this is maybe stripping SSL and looking for some indicators. So I've put a few there. Maybe the content types might help. Obviously, for domain fronting, it's where the initial SSL tunnel, the host name there, doesn't tie up with the underlying host header. So, for example, when CloudFront domain fronting was a thing, you could maybe look for Cloud App or whatever under the underlying connection, if you're stripping SSL, that is. But if you're not stripping SSL, really all you're going to see is someone opening a connection to a Google endpoint or Cloudflare endpoint, etc. So that's interesting. Obviously, heuristic-based detections, we're talking probably relatively small amounts of data here, but maybe you can do something with pattern of life, etc. I've also mentioned, so my advice at the moment is, and it's pretty hard when it comes to Google because of the way they've architectured it, but maybe block access to the DOH endpoints if you're in your enterprise for the time being. Maybe you can roll your own, so you can host your own DOH server internally and maybe do this at the top of the chain to get the security benefits. But this is something, maybe attackers can hide on the wire with this technique. So that's pretty much all I've got time for. As I say, I'll be publishing the code later today under the Spider Labs GitHub. I also wanted to shout out to some other projects from some colleagues. So we've been, so Sheeple is a kind of, it's a user behavior simulation tool, which you can deploy to lab environments, which is super cool. Also, Social Map is a OSINT tool on steroids. These are all open source. A few other projects which are coming from Spider Labs in the kind of previous couple of months. But that's pretty much it from me. Have I got time for any questions?
Unfortunately, we do not.
Okay, so if you have any questions, then please come and reach me. I'm around for the next couple of days, or reach me on Twitter. DTM Security, really appreciate a follow as well if you're interested in red team stuff. So